I'm just going to wait a few more seconds for people to join us in case anybody's needing a little extra time to sign in. We'll start at 1 after. All right, let's get started now. My name is Paul Gannett, and I'm going to be one of your co-hosts for today's webinar. Thank you for joining us. We're glad to have you with us. Today we're going to be talking about water quality monitoring applications and lessons learned, as well as giving you time to ask questions, and we'll hopefully be able to provide you some good answers to those questions. So let's jump right on in. Oops, there we go. The webinar is going to run for about 50 minutes with roughly 35 minutes of presentation time, and the rest is going to be time for answering your questions. And you can send questions in as we go, and some of those we'll answer as we go, and some of them we'll save for the question and answer time. And I also want to thank those of you that sent questions in advance. Some of those we'll actually work into the presentation, and some of those we'll save for the question and answer time. So hopefully we'll get to all the questions. And you'll see over on your control panel, you have a place where you can type in your questions. So that's where you'll enter your questions. And the other thing is this webinar is being recorded, and within a couple of days after the webinar, we'll be sending out a link in an email so you can watch the recording again and refer to it as you like. So in the way of quick introductions, my name again is Paul Gannett. I'm the Principal Product Manager for HOBO Products. I've been with Onset now for over 28 years. I live here on Cape Cod, as well as Onset is located here on Cape Cod. And the ponds, the streams, the estuaries, and the ocean around us are really an important part of our economy and our recreation. It's part of what we like to do. So we're all about protecting those valuable resources. I work closely with our engineers to develop our HOBO loggers. I've been doing that since I've been here, and you know, we're still working on new products today. And I also work with our technical support and sales teams if they have questions. So I learn a lot about what your questions are as I'm working with our sales and support teams. Also here with us today is Tyler Buck. He's a senior product manager at Lightcore. He's got a ton of experience working with environmental monitoring instruments and systems. He's relatively new here at Lightcore, but we're really thrilled to have him here and bringing all that experience with him. And in particular, he manages our light sensor portfolio, which we'll be talking about in a little bit. And he's, as he notes here, he's driven to find solutions to your problems. Also with me today is Andrew Thompson. He's our sales manager for the water resource management markets. He's been with us for 5 years now. And I have to say, he's the guy I go to when I want to get a good perspective on what the market is looking for and what directions they're going and what our users need. So he's a great resource. Glad to have him working with us, and he'll be able to answer a lot of your questions today, and he loves working with you out in the field as well. Just a little bit of history on Onset and changes happening at Onset. We were founded back in 1981, and we do make the HOBO data loggers, which we're best known for, and we're here on Cape Cod. Although we do have some remote employees as well these days, that's kind of part of it. And but last year we were purchased by Lightcore, and now we're very much integrated into the Lightcore environmental product family, and we're just thrilled to be working with the folks at Lightcore. I think we have very complementary skills and that's really going to help with our product development and serving customer needs. And for those of you who aren't familiar with Lightcore, they're a global leader in greenhouse gas measurements, very high-end scientific measurements that they're able to provide, as well as some sensor technologies like their light sensors, which we'll talk about, and just bring a ton of scientific experience and expertise. And I know this is coming up soon. This is actually next week. It's going to be the Lightcore Connect conference for users. And that's going to be exploring a lot of different solutions for climate change mitigation, soil health monitoring, improving crop yields, disease research. And I did check with our marketing manager who's running this program, and she says there's still spots available if any of you would like to join us. And I did check the weather. It's going to be in the 80s next week, so it's not a bad place to be if you have time and the desire to join us. Both Tyler and I will be there, and we'd love to have a chance to meet with you. So here's our agenda for today. We're going to be starting out with kind of an overview of the HOBO water quality loggers and talking about some of the applications. And then I'll be talking about some of our web-enabled cloud-based solutions and wireless water quality monitoring options. Then we'll talk a little bit about connecting third-party sensors. Then I'll turn it over to Tyler to talk about connecting Lightcore quantum sensors. And then we'll have lots of time left for answering your questions. And I know that's an important part of this, so we're going to make sure to allow time for that. And what I'm going to do is I'm going to turn off my camera at this point. You've probably seen enough of me. So the HOBO water quality loggers. I'm going to focus today on the HOBO MX series water quality loggers. We've been filling in that range. We do have an optic USB series that many of you have been using over the years, but for new applications, we're recommending the MX series loggers. And just a little bit of on what they provide. First off, there's a wide range of measurements available in this platform now for temperature, water level, conductivity / salinity, dissolved oxygen, pH, and light. And all of them feature Bluetooth data offload with mobile or Windows devices. You use that Bluetooth to wirelessly communicate with the loggers. So there's no cables that have to be plugged in. It makes it real easy to access the loggers, no base stations. And the housings, similar durable housings to the loggers we've been selling for a lot of years for both freshwater and saltwater environments. Most of the MX loggers now have user replaceable batteries, so you can get many years of use out of them. And the software, the app that runs on the mobile devices or Windows is called HOBO Connect, and that's used for configuring the logger for things like setting the logging rate. It's used for data offload and data sharing, and it runs on iOS, Android, and Windows platforms. And another thing that we're known for is our affordable prices, and I'll show you a little bit more of that on the next slide. Here's just a sampling of not all the loggers, but a pretty good representation. The different parameters that are available in the MX series. Oops, you don't want to see that. I thought I turned off my Teams, but sorry. Temperature and light, and you can see the price is starting at $79, and these are just different permutations. This one has a light sensor in it as well for $95. We have the tidbit, which provides higher accuracy, greater depth rating at a higher price. In water level, we have the MX water level loggers, which start at under $400. And then we have the direct read water level loggers, where the sensor stays in the water, but the logger head sits above the water. And that just makes it easy to offload the data, with that Bluetooth communications. We'll talk a little bit more about that when we get to some of the applications. We also have a pH logger. Just last year, we introduced the MX800 series loggers, and this is a little bit more of a modular approach. We have loggers. We have two loggers in the family, and then a range of sensors that can connect to those loggers in various combinations. So the MX801 logger is designed for submersible applications, and the sensors connect directly to that, and that makes them easy to deploy on the bottom of the water so that they're out of the way. People don't see them. They don't get in the way of boat traffic. And probably that's the most common way that our loggers are deployed. Then we also have the direct read loggers, which have the cable similar to that water level logger I was talking about on the previous slide, that allows a sensor to be in the water while the logger itself is above the water surface for easy data offload. You just make sure to have the appropriate length cable connected to the logger. In the way of sensors, we have CTD sensors, which stands for conductivity, temperature, and depth. And those also measure salinity, of course, which is derived from the conductivity and temperature data. Those are in 4 different ranges. I think I had a question in advance on ranges. Smallest range is 13-foot range, which gives you nice accuracy over that narrow range. And we have up to a 250-foot range for deeper applications. We also have a conductivity and temperature sensor, which again can be used for salinity. And then we have a dissolved oxygen sensor. And so any of those sensors can be connected to either of those loggers. And you can also connect 2 of those sensors to one logger, which is pretty powerful. It allows the one logger to be shared for 2 sensors. The adapter comes with a protective guard that protects the sensors. And the loggers are smart enough to take the data from those 2 sensors and combine it to extract other parameters. For example, for dissolved oxygen, you typically need to compensate for salinity. So this logger will directly calculate the salinity adjusted DO if it has a DO sensor and a CT or CTD sensor attached to it. We do recommend deploying these in a PVC pipe, a 2.5-inch PVC pipe to go over the logger, just as an added protection for that logger. And the 2.5-inch PVC pipe slides perfectly over this the housing that protects the sensors, and you just use a couple of screws to secure that in place. That works out pretty well for making a pretty bulletproof deployment scenario. Yeah. So the software, HOBO Connect, which I mentioned, this is just a couple of screenshots from it to give you a sense for it. But this is the on the left is the main configuration screen where you can configure the loggers. You can view live data if the logger's right next to you. You can download the data after pulling it up, or in the case of the MX802, you can download the data while it's still deployed. You can stop the logger. There's different functions that are available depending upon how you've configured it. And you could also use the HOBO Connect to plot out the data, view the data. And up here, you see the little box with the arrow in it. That activates the sharing function. So you can share your data via email, text, Google Drive. There's a lot of different options for being able to share the data once you're on a platform like an iPhone, for example. A lot of flexibility there. There's also HOBO Connect can do some processing of the data, like it can calculate %DO data if by combining a barometric pressure file with the DO data, if that's if you have those 2 data files. So that's an option. A lot of power in HOBO Connect. And another thing you can do is you can set up HOBO Connect so that it can forward your data to HOBOlink. Now, HOBOlink is our cloud-based platform for centralized data access. And HOBOlink is actually being linked to Lightcore Cloud. So there's going to be one combined platform where you can see both your Lightcore instrument data as well as your HOBO data all in one place. So it's a great centralized place to access all of your data and set up dashboards to view the data exactly as you want to see it. It also provides data backup and archival. And it does require an annual data plan for the service. You don't, so again, it's optional. You don't have to use this, but it's a really nice convenience, especially if you've got a lot of loggers with a lot of data that you're trying to manage. It just makes that process a lot easier. Right now, HOBO Connect will support upload to HOBOlink for all of our MX series loggers, except for our newest ones, the MX20L and the MX800s. And the reason for that is just we're in the process of making these fairly significant changes to HOBOlink. So we wanted to get those in place first, and then we're going to bring in the support for these new loggers, which will be happening soon. So now I'm going to switch gears a little bit and talk about some applications, some of the early applications for the MX800 loggers. Like I said, we just introduced these last year. One of our early customers was the Swedish University of Agricultural Sciences, which interestingly does study water environments as well. Maybe that's the aquaculture connection. They chose our MX801 loggers, the submersible loggers with the DO sensors, and they're using them for monitoring oxygen in rivers over a pretty large span of rivers. They're critical for salmon habitat and other fish species, and they've been hearing reports of low oxygen levels, which could be a major problem if those are to become more common. And there hasn't been monitoring of the oxygen, so they decided it was time to start monitoring the oxygen and getting a better handle on what's happening. So they want to understand what's happening. They want to identify areas that are at a higher risk, and they want to consider implementing policies to protect those waters, such as having industries near those waters file sustainability reports that include oxygen data. So they're trying to stay ahead of the game, which is the way to do it. And here's an interesting picture of how they mount the DO logger to the a weight. In this case, it's what do you call that? A disc brake rotor, which is nice and heavy, and it's got some holes in it for attaching the zip ties. In this case, they were attaching them directly to the rotors, but we actually recommend putting the logger, in this case, in a PVC pipe, just to give it a little added protection from stuff that might be kicking around and flowing around down in the waters. But in this case, they didn't think that was necessary. We do sell a what we call it a housing for these loggers, which is basically a PVC pipe with some holes in it. So, but you can make your own. I'll show you an example of a user PVC housing in a couple slides. They were deploying at multiple depths, and one of their comments back was they like the calibration routines that are built into HOBO Connect, making it easier to calibrate the DO sensor in these than with previous loggers. Here's another user, a little warmer environment down in Florida. This is Austin Fox, and he's studying the Banana River estuary, which is in the area of Cape Canaveral in Merritt Island. And it's a real important waterway. They attribute some $800 million annually of business that's related to that area, the commercial and recreational activities that are going on in that area. So that's pretty significant. And the data that he's gathering is being used by several different groups. The local government agencies, they're using the data to assess the effectiveness of water quality improvement programs that they're doing. The state government agencies are using the data to set water quality targets and monitoring requirements with Austin's experience and expertise kind of added to that. And he's doing a lot of research into what's driving the hypoxia events. Hypoxia is when the oxygen levels go down to excessively low levels, which is too low for the fish to survive in. So you definitely want to avoid those. And they're also using the data to identify sites for seagrass and oyster restoration projects, which help to improve the water quality in that area. It's all kind of part of that ecosystem interplay that's important to keeping good water quality. So again, deploying them over a large 200 square kilometer area, and you can see the PVC housings that he's making. He's got a kind of a clever approach here by putting a T pipe on the end of it, and he uses that to run a chain through, and that chain is what he uses to attach the PVC housing to structures so that he can go and retrieve the data. Here he's attaching it to a post for a sign in the estuary. So I thought that was pretty good way of mounting them. And he's looking at the data in a few different ways. Of course, he's looking for those hypoxic events where the oxygen levels go super low, but he's also looking at the diurnal variations in the dissolved oxygen. And that's like an early indication that there could be oxygen issues in that area. So trying to stay ahead of the game by looking at the data before it gets to be hypoxic. And some of the things that he likes, I'll talk about those. Well, let me talk about this mounting first. It just gives you a little cleaner look at his mounting. So this is before they've been deployed in the water, clearly. And those little aqua blue rings are discs that they print out on a 3D printer for basically just holding the logger in place and the sensor in place within that PVC housing. So I thought that was, again, a pretty clever way of mounting the loggers. And so now talking about some of the things that he likes, he's used SONS extensively in the past, and for monitoring a bunch of parameters, but those are bulky, they're expensive, they're a lot of maintenance, calibrating all the sensors. So he can get most of what he needs just with the DO logger. DO and temperature tells him a lot of what he needs in a much more affordable and easy to deploy platform. And because of their price point, he actually has like an extra set of them. So when he goes out to service them, instead of trying to calibrate them in the field, he swaps in ones that he's calibrated in the lab, and then he brings back the ones from the field to calibrate in the lab. So it just gives him that ability to swap them out, saves time, and it also results in better data quality because he's able to calibrate them in the lab. He likes to use the replaceable batteries, get more life out of them. The new DO sensors have a 2-year cap life, makes it easier to manage than having to replace the caps every 6 months. And because we do user calibration, this was one of the questions that I'm just remembering came in advance. Somebody was asking about the DO calibration. Is HOBO Connect allows the user to recalibrate during the deployment or when they put in a new cap after 2 years. They really can calibrate as often as they like, depending upon if they see any drift due to following, they might feel a need to recalibrate. So they can easily do that with our calibration software. And another thing Austin liked was just the Bluetooth. It was a little more reliable than previous communications. So here's the deployment, actually closer to home. That's me. Deploying the MX802 direct read loggers with a CTD sensor. So you can see it here on the dock, and you can see the cable here. I think this was our, I forget which length I used. The water change is about 10 feet. I think I used our 4-meter cable or 5-meter cable for this, because it was pretty, the dock's pretty high up. And I made a stilling well that I mounted to the piling on the dock. And you can see, if you look closely, I used hose clamps to attach the stilling well to the piling. And I used slotted PVC at the end of the PVC pipe to allow the water in, but to keep the silt and the other crud out of the stilling well. That's a common challenge, is to keep that silt out, and we recommend slotted PVC that has very fine slots, the kind of slots that are so thin that you can't see light through them. They're just enough to allow the water through. I also used the onset well cap. That's this yellow cap at the top and the mounting disc. And one of the things is, it's hard to see here, but I've already attached the mounting disc to the top of the logger, so I can just feed the sensor down into the stilling well, and when it gets to the bottom, it actually is supported on that disc that's on the logger, so it doesn't go any further into the well. You don't want it to fall into your well, of course. And I've also used our copper anti-fouling guard. We sell anti-fouling guards for our sensors, as well as that 2-sensor adapter that I showed you earlier, that helps slow the rate of fouling. It doesn't stop it, but it helps buy you time, so you don't have to go out to service quite as often. And just some of the advantages of this direct read configuration. No, that's not my boat behind there. I don't have a boat that big. As you can read out the data without having to pull the sensors up. So I'm actually reading out the data right now. And the logger's still in that stilling well. It's in a plastic, well cap, so you can read out that data wirelessly. It's got like 100-foot range with that Bluetooth, and just makes it so much more convenient. And you can get the water level data directly without having to do any post-processing, because the logger includes a barometric pressure sensor in it, and it does that calculation of taking the barometric pressure and the water pressure data to calculate the water level. And you set the reference water level at the beginning of the deployment. So it's a pretty easy to use system. So what I want to do now is switch gears to some of our web-enabled stations. We call them remote monitoring stations. And at first, I just start out just kind of in general. What are the advantages of remote monitoring stations, or IoT, as a lot of people refer to it? It allows you to view to current conditions at your sites from anywhere you are. And you can have all your sites together. You even have like a map view on our software, so you can kind of see how the conditions compare at different sites. It saves the time of having to go out to the field to offload your data. You can get alarm notifications if critical limits are reached or if there's a system problem. We have plug-in temperature and water level sensors that plug directly into these. We also have weather sensors that can plug in there. For example, here's a rainfall sensor, which is often important and is part of water quality studies. We have analog inputs for connecting either light core sensors or other third-party sensors. And because this data is on the web, it makes it easier to share the data with other users or water monitoring networks. And we have a couple of different levels of remote monitoring stations. The kind of the entry level one is the micro RX station, which is pictured on top. And the nice thing about it is a integrated station. It's got a solar panel built into it. It's got the mounting ears, and it's fairly compact, so you can mount it on like PVC pipes. It's small enough to do that. You can get it with an integrated water level sensor input, and then it also has inputs for 5 other sensors, such as rainfall or other weather sensors. The RX 3004 station also has the integrated cellular, but it's got a little more expansion capability. It has these modules, so you can put in different modules depending upon your application. So you can have an analog input module for connecting sensors. You can have a relay output module. You can have a module in here for communicating with our wireless sensors, which I'll talk about next. And well, it also has inputs for 10 wired sensors at the station. So a lot of flexibility there. And here's our wireless sensors. We call them HOBOnet. It does require one of our RX stations as a gateway. Oops, let me grab some water here. And you can have up to 50 HOBOnet sensors connected to one gateway, so a lot of possibilities there. It's a mesh networking scenario, so you can have them talking through each other to extend the range. Each connection has a 1,500 to 2,000 foot range, and we do have repeaters available. And we have a range of sensors in this HOBOnet network option. And next, I'm going to talk about a new one. This is just a little preview. It's not quite introduced yet, but we promised we were going to give a little preview of it at this webinar. So here it is. It's an analog input HOBOnet module or moat, and it's full HOBOnet capabilities and mesh networking and all that. And it has the ability to connect up to 4 analog sensors into it with high accuracy inputs and high resolution. It's got a wide range of input ranges, including a 160 millivolt range, which is good for some of those low output sensors, such as light sensors, for example. You get better accuracy when you connect them into that narrower range. It also has the ability to scale to user units, of course, linear scaling. And it's either solar powered, as you can see, it's got the built-in solar panel, or it can be AC powered. And at this point, you've heard enough from me, and you could hear my voice was starting to go anyway, so it's time for me to turn it over to Tyler. Take it away, Tyler.
All right, thanks, Paul. Hello, everyone. I'm really excited to introduce a couple of our underwater quantum sensors, the LI-192 and LI-193. So Paul gave a great introduction earlier about LICOR in the presentation. But for those of you who don't know, the product that founded the company over 40 years ago was actually a quantum light sensor. And our light sensors are known as a standard in the industry for their accuracy and their performance. They're even used as reference for other light sensors in the market. So going to this now, we know that underwater organisms use direct and reflected light for photosynthesis. And for this reason, researchers want to measure both the downwelling light and light reflected from the bottom of the surface, or light reflected from suspended particles in the water. And both of these sensors meet those needs. So these sensors are engineered to measure photosynthetically active radiation, I'll call it PAR now going forward, and making it ideal for assessing light availability for terrestrial and aquatic plants and photosynthetic organisms. So the first one we'll talk about here, shown on the screen on the picture on the left, is our LI-192. If you are familiar with our product line, this is very similar to the LI-190R that's used for more traditional indoor and outdoor applications. This one is designed specifically for underwater use. And when we're talking about measuring light for PAR, we're talking about measuring light between the 400 and 700 nanometer range, which is what is used for photosynthesis. This sensor functions effectively in both air and water, but it's specifically designed to work in water at depths up to 560 meters. This sensor is also cosine corrected. And what that means is cosine correction is really important when you have low light levels, or when light isn't overhead and it's at a low angle. Basically, what this means is it ensures that your measurements are accurate in these situations and are useful following Lambert's cosine law. These sensors are also built with corrosion-resistant materials, ensuring durability in both freshwater and saltwater environments. So when we're talking about applications for these types of sensors, in oceanography, it can be used to measure downwelling PAR. So basically how much light penetrates the ocean surface to assess photosynthesis in marine ecosystems. Limnology, again, measuring light penetration, but this time in lakes and rivers to evaluate aquatic photosynthetic activity, or you can either monitor other factors affecting water clarity or ecosystem health. For turbidity, you can look at how turbidity affects light availability for submerged plants and algae. And you can also use this for vertical profiling to see how PAR changes with water depth. We also sell a lowering mount as an accessory. That's what you see on the picture to the left here. where you can attach these instruments for those types of studies. Next slide, please. All right, the next one that we're going to talk about is the LI-193. So it's similar to the 192, it's still measuring PAR. However, you see that it's got a different design, it's got a sphere on it. And unlike planar sensors that only capture light from one hemisphere like the 192, the 193 measures light from all angles. So both direct and scattered, so giving you more of a complete picture of the underwater light environment. It's very, like I said, it's similar to the 192, but it can be used in air. You could even use this to do measurements under like plant canopies, things like that. But you can use this underwater in depths up to 350 meters. Again, like the 192, it's constructed with corrosion-resistant materials suitable for both freshwater and saltwater environments. Applications for this, again, studies in highly diffuse light environments, turbid waters. Again, I did mention you could technically use this too in air environments under dense plant canopies, if that's of interest. Deep water ecosystem studies where light scattering is significant, or you can also use it for photoplankton, seagrass, coral reef habitats, those research studies where penetration of light is more complex. So as you can see, both of these sensors are very similar, but they fit different use cases based on their application. Next slide, please. Okay, so let's talk about how you can connect these to HOBO remote monitoring stations. So as Paul mentioned earlier, we have the analog mode soon on the horizon. We're really excited about that. So we have a couple of different options of how you would connect one of these sensors to that. When you purchase one of these sensors, you have a couple options. We have millivolt adapters that change the current signal into a millivolt signal. So we have one that is at a standard millivolt adapter that's standardized to the specific sensor that it's matched to. So it'll give you a 0 to 10 millivolt output. Also, let's say you already have one of our 192 or 193 sensors and you don't have that standardized millivolt adapter. We do have a fixed resistor millivolt adapter version that you can plug in. So no need to buy or go and get another sensor. You can just purchase that and hook it up and plug it right in. And that's what's pictured in the upper right-hand corner there. That's what it looks like. Okay, let's say if you wanted to directly connect it to an RX3000 weather station, you can do that as well. You will need the analog module in the RX3000. If you have a standard LI-192, 193, you can. We also have a light sensor amplifier that you would attach to that as well and plug directly into the RX weather station. And we also have BNC connector or bare lead connector versions, sensor versions of this, and also of the light sensor amplifier. So very flexible depending on what your setup is, so it can fit into either one of those. So using either of these methods, you can seamlessly integrate our underwater quantum sensors into the HOBONet system, so you can enable continuous and reliable power monitoring from anywhere with HOBOLink. I think that's all I have. I'll give it back to you, Paul. Thank you.
Thanks, Tyler. So, hey, we're actually not too far off schedule. We're doing good. So now we have time to answer some questions. I see that some of you have sent some questions in, and Andrew's, with specific answers. He's been answering some of those. But what other questions do you have? Have you queued up any? Do you have any queued up there, Andrew, to talk about?
You know what, Paul? I think you and Tyler must have done a very good job, because there wasn't that many questions. So, like Paul said, feel free to fire them at us and try to answer as they come in.
What I'm going to do is call up some of the questions that were sent in advance. I think there's a couple there that we might want to address.
So we just had one, Paul, which is, what is the best way to mount the tidbit temperature loggers? And I can kind of jump in if you want, Paul. There's
Yeah,
so
go
one
for
of
it.
the thing about the Tidbit loggers is they actually come with a mounting boot. So that's good to, you can use it on a zip tie. It really depends on the application. If it's a stream application and you're mounting it to a piece of rebar, if you're actually putting it in some sort of protective housing, it all depends, but they do come with a mounting boot so that you can use zip ties. You could even screw it to a block. It all depends. So there's multiple ways, PVC housings, different things. Anything else, Paul, for that one?
Yeah, zip ties. That's, I think you
Yes.
covered.
Okay.
Yeah.
There's
Okay.
it. Yep. Here
This,
they come.
yeah. All right. There's a question here on will we provide a nitrogen sensor in the future? And that is one of the things that we're considering. We don't have anything to offer right now. It's a little trickier measurement and to do it right. So we want to make sure when we come out with a sensor that we do it right. If you've got any suggestions on good sensors that you like, you say, hey, this one does a really good job, send it our way. That might help us out. So thanks for that suggestion.
And then Paul, so the next question, which I can answer, and then you can chime in if you want, is if my monitoring points are several kilometers apart, are there options to minimize the number of HOBONET data plans I need, or will each microstation need one? So Paul touched on it a little bit. It really does depend on distance. We offer what is called the HOBONET wireless system, which allows you to do multi-point measurement in a given area. I think he mentioned, if let's say you have a station, for example, and you're looking to do water level or temperature or soil moisture, you could put one of those wireless sensors that uses radio communication up to 2,000 feet line of sight. And what's great about it is you can hop up to 5 times beyond that. So you can put a sensor out 2,000 feet, 2,000 feet off of that. So you can get a really good range in network with that system. When you're doing that, it keeps the data plan specific in the cost of the data plan specific to that one single station. So that's a way to get multiple measurements on a given site. As far as if they are too far away, you can't bridge the gap with another sensor or a repeater, you would have to use another station. However, we do have a really good we have good plan, or the price of our plans are pretty reasonable for a single micro RX station. If you're not doing too many measurements, it's as low as $99 a year. So very low cost. I think one trip will eat that up.
All right, thanks. I'll take the next one. There's a question on asking for a feature comparison between the MX800s and our U26s and U24s for DO and conductivity measurements. So yeah, I'll just briefly hit on the main differences, but because I know a lot of you are used to using our U24s and our U26s for your application. So what's new and different? In terms of the DO measurements, the new DO sensor is more accurate. It has a 2-year cap life instead of a 6-month cap life, so you can go longer between having to replace the caps. And because it's part of the MX800 family, it has the replaceable batteries. So, and yeah, I think those are kind of the key differences for the DO measurements. In terms of the conductivity measurements, the new conductivity sensor for the MX800 family has four electrodes, and so it's got a much wider measurement range. The one sensor can measure from very pure fresh water all the way up to 80,000 microsiemens per centimeter, which is way above your typical seawater. So that's probably the biggest thing. It's going to not drift like the U24 sensors would over time. It's going to be much more stable over time. So those are probably the biggest differences in the two between the older and the new generation. Again, replaceable batteries for the
Yeah.
MX100s. You want to add
Yeah,
anything to
no,
that, Andrew?
I'll add to that. And not as much on the sensor side, but the platform too. I mean, being able to have both of those sensors on one single unit, or being able to swap them for different deployments. Maybe you're interested in dissolved oxygen in the summer months, but you want to switch it to conductivity in the winter due to location and maybe road salt runoff or things along those lines. So it really opens up your capabilities to expand and add sensors down the line, use it for different applications. So that's one of the biggest differences with the MX800 in general.
Yeah, excellent point.
And I could, the other one point too is memory. Comes with
Oh
far
yeah.
greater memory than the U26 or the U24, with up to 750,000 measurements. And it comes with a whole list of different parameters that it offers because of it, and calculated ones like, TDS. I'll give a reading for that when you do conductivity. When you're using both the DO and the conductivity sensor on the same MX800, you'll get salinity adjusted DO levels. So all of that is kind of done right through the app, right through the product. So there's a lot of benefits on that end with the platform.
Good points.
As far as, so we got another question here that says, do you offer an ORP sensor? We don't offer one for the MX800, but some of our partners that we utilize for water quality sensors to do real-time monitoring and tie them into the RX3000 that you saw today, or even the analog moat that we're coming out with, they offer an ORP sensor that fits in nicely. So we do have an option for that. So feel free to reach out if ORP is something that you're interested in.
Got a question here. Can we import U20 barometric files into HOBO Connect to compensate for MX800 water level data? And yeah, the answer is yes. The data assistant in HOBO Connect allows you to import CSV files, and it's a pretty it's almost just as easy as importing HOBO files directly from our loggers. So you'll find that very easy to do.
Great. So here's the next question. Is there any way the solar panel can be replaced by a powerful battery for powering the system? I will say I find in most cases the power supply that we provide is typically enough. On the micro RX station, it has the built-in 1.7 watt solar panel. Everything's pretty low power, so that works for that. But we also offer a 5 watt option and a 15 watt option. So those are available if needed. And then beyond that, Paul, correct me if I'm wrong, but I'm pretty sure we sell some sort of whip that you can attach to some sort of battery to power it outside of that as well.
Yeah, we do. We have an option for wiring an external power, such as from a car battery with its own solar panel system. So yeah, you can, if needed, you can do that with the. That's with the RX 3000. I don't know if you can do that with the RX 2100. I'm not sure on that one.
Do you
I'm pretty
want
sure you
to?
can actually.
Yeah. There's a question here about the cost. I'm just not sure exactly what product that is, but feel free to reach out and we can help you out with rough costs. The next one, I don't know if we can answer this, Paul. The one regarding the LI 192 and 3 being available.
Yeah, that's a distributor question. That's something that yeah,
We can follow up on that one. We have
yeah,
all those
that's
questions and we can
yeah.
follow up at a later time.
We'll
So the
follow
next
up.
question I have here is, how often do you have to calibrate the DO and connectivity sensors? I'm in a remote location and access is difficult. I'll say that when it comes to calibrating all of these different parameters, DO and conductivity hold calibration pretty well, but it really is going to come down to your deployment, right? And where you're deploying, what kind of environment it's in. As far as, I think it's less so calibrating the sensors as much as it is going out there to remove biofouling. That's going to be the biggest cause for drift over these lengthy deployments. So being conscious of that is what you're more interested in.
Yep, agreed. There's a question here. Do you have options for automated alerts? With the RX stations, our web-enabled stations, yeah, those will do automated alerts, either text messages or emails that you can set up. You can even set up multiple alert addresses if you want. And those can be either based on measurement levels, so maybe when the water level gets to a certain level, you want to get notified, or it can be system issues. For example, if the station solar panel got knocked off or something and suddenly it's not recharging, if you get a low battery, you can get what's called a system alert to tell you that, hey, your battery level's going down too low, and you can go out and service it before you lose data. So those are important as well.
This next question here actually kind of goes along with some of the benefits of the new sensor technology. The questions, I'd like to know a little bit more about the calibration process for the sensors. So this is actually one of, I think, the great features of the MX800. Number one, you can calibrate everything right through the app. It's extremely quick and easy, something that you can do in the field. It takes no more than minutes to calibrate. I know in many cases, with some other technology on the market, and you're bringing them back to the lab, you're calibrating it. It can take up to a day to do something along those lines. The MX800, it's quick and easy, done right through the app, and that's for both dissolved oxygen and conductivity.
Yeah, and with the conductivity calibration, it's done with calibration solutions now, which is, I think, the way most of you have been doing it. We had with our older loggers, you had to do it with like a field calibration measurement, which you can still kind of do if that's your preferred method, but using the calibration solutions is in general an easier way to go.
There's one here, question regarding cellular loggers and accepting Modbus inputs. That is not something that we currently offer on the HOBO side. I'm not sure if that is the case or not on the Lycor side. Tyler, are you familiar with that at all?
I am not, but we can look into it and get back to you on that.
Awesome, thank you. There is a question here regarding if you can, if the meeting's set up to ask questions verbally. It's not set up that way, but we can absolutely, my contact, I'll send it to you right now. And if you have questions, feel free to reach out. I'd be happy to discuss any questions that you have. I think from what I see, I think we've answered everything that's come in.
Oh, this is another late breaking question. Is there a pH sensor for the MX801? Not yet. For now, you can use the MX2501 to monitor pH. But at some point, we probably will add a pH sensor that can connect directly to the 801 as well.
Another question here, can you connect the conductivity probe to an RX station? So similar to what I was mentioning about ORP before, we have a great partner with some of these same measurements that we carry, or some different ones as well, but some of the same measurements that we carry for the MX800, they offer as a great sensor solution to tie into our RX 3000. So that is one of the sensors that they offer, and that's something that if you're interested in, we'll reach out. I have your information here. I can follow up after to talk to you about how that would work.
And there's a question about satellite connectivity for downloading the data, and we do not have that at this point, but that's certainly on our wish list of things we'd like to add in the future. All right. Yeah, I think what time is it? Yeah, we're coming up on the end time anyway. So why don't I kind of flip to the next couple of slides just so you can refer to them. Oops, where is that? There it is. Hit the wrong spot on the screen. So I'm sure you'll have other questions. Feel free to reach out to us at any time, and also feel free to refer to our websites. And I say websites because we're kind of in the process of merging them. right now, of course, we have our onset comp website, which you'll see if you look closely there in the upper left. It says we're a Lycor brand now, but we've got a wealth of resources there on using the HOBO products, applications, application notes, webinars, all sorts of things you can refer to there. And we're in the process of integrating into the Lycor .com website as well, which will soon have information on all the Lycor products and the HOBO products in one place. And of course, the light sensor, the information that Tyler talked about, that's all available on Lycor.com as well. So 2 websites to refer to. And at this point, just really want to say thanks for attending. We're really happy you joined us today. And thanks for the good questions. And as you exit, be sure to share your feedback and let us know if you'd like us to follow up with you for any more details. So thanks again.
Thanks, everyone. Great job, Paul.